Hello all, in this video we will see factorials in C programming. So how we can calculate factorial by using loops. So that is what we are going to discuss in this particular video. So why we have to care about factorials in the first place? Factorials are very useful when in the computer science to find the algorithmic analysis. So if you want to compare algorithms or if you want to measure the time and space complexity, we can use factorials in algorithmic analysis. That is the one use case you should remember. When it comes to probability and statistics, factorials can be used in binomial distribution and Poisson distribution, and factorials can be very useful in permutations and combinations. So knowing factorials and the background of factorials can be really helpful in programming. So this is very important to know how to calculate factorial by using loops, and how to calculate factorial by using recursion, and how to calculate factorials of a big number that we are going to discuss in the future videos. So knowing these things will certainly help you in computer programming. Now without any further delay, let's get started. First of all, how we can calculate factorial. So if you observe line number 5, 4 factorial can be calculated as 4 into 3 into 2 into 1, and mathematically speaking n into n minus 1 factorial. How we can convert this into program? That is a big challenge, right? So there is one more limitation. So factorials can rapidly grow. For example, 1 factorial is 1, 2 factorial is 2, 3 factorial is 6, and 4 factorial is 24, 5 factorial is 120, 6 factorial is 720. If you see the difference between two factorials, this is enormously huge, and 7 factorial and 8 factorial, 9 factorial, that would be a large numbers. So these are growing so fast, our C data types cannot hold that value. Whatever you are seeing right now on the computer screen, whatever you are seeing this program works till only 20 factorial. After that it will overflow because of the limitations we are having with the data type sizes. Okay, so this is the largest, this is indeed the biggest data type, largest data type, which can hold the big numbers. On line number 12, we are declaring some variables called n factorial and I. I is the looping variable, n is the user input variable, and factorial, this is where the result can be stored. The factorial, what I am highlighting right now, this is where our result can be stored. This is the user input value, and this is the looping variable. And these are declared as unsigned long int because factorials cannot be negative, and because of the factorials are very big numbers, I am declaring the data type as unsigned long int, which can store maximum number of factorial values, and this program will work only for 20 factorial. I mean to say this program work until 20 factorial. After that it won't work. It will overflow. You won't get the correct answers. So on line number 13 we are printing one message, enter a number by using printf. On line number 15 we are taking the input from the user keyboard by using the scanf. And what is the n is declared as a unsigned long int. So what is the format specifier for n? Unsigned long int. It is percentage LL long unsigned U. That is the format specifier for unsigned long int, percentage LLU. So whatever the user enters, that will be stored in the memory location of n. Once the input is ready, we will perform the factorial calculation by using any of the loop. I am taking for loop because it is very easy to understand. For I is equal to 1, because if you put I is equal to 0, 0 into factorial, that will result in 0. Okay, so this won't be correct. If you multiplied with 0, no, that will be a, that won't be a good, so that won't give the correct answer. So I am starting the loop from I is equal to 1, I less than or equal to n, because I am checking the if the let me trace this 16, 17, 18, 19 lines with the hard run. We can dry run this code so that you can understand it better. So I'm having one picture here. I will open. Let us say n is equal to 4 and 4 factorial is 24. Let us try to dry run this piece of code. What I am highlighting, let us try to dry run this code. For example, if I is equal to 1, because I am storing I is equal to 1, right? 1 less than or equal to n, that means n is 4. For now, assume n is equal to 4. 1 less than or equal to 4, condition true. We are going inside the for loop. Factorial is equal to factorial into I. That means the initial factorial is 1, because 1 into something will result in that number only. If you assign factorial is equal to 0, then the result is also 0. That won't be good. So that is why factorial is equal to 1. 1 into I is equal to 1. 1 into 1 is 1. So now I value becomes 2. I value becomes 2, and we are moving to the second iteration. In the second iteration, I value becomes 2. 2 less than or equal to n, condition true. 2 less than or equal to 4, condition true. Factorial is equal to factorial into 2. That means the factorial value is 1. The previous iteration, the factorial value is 1. Now factorial 1 into I value is 2. 1 into 2 is 2. Factorial becomes 2. In this iteration, the second iteration, I value I plus plus, I value becomes 3. That is the end of the second iteration. Factorial is 2 and I value is 3. Now we are moving to the third iteration. So third iteration, I value becomes 3. 3 less than or equal to 4, conditions true. And factorial is equal to factorial into I. Factorial previous value is 2. 2 into 3. That means I value is now 3. 2 into 3 is 6. Now factorial becomes 6 here. And I value will be incremented after this. I value becomes 4. We are moving for the final iteration. 4 less than or equal to 4, condition true. Factorial is equal to factorial into I. The previous factorial value is 6. 6 into I means 4. 6 into 4 is 24. And factorial is 24. I value becomes 5, because I is equal to I plus 1. I plus plus, right? That is increment operator. I becomes 5 here. So 5 less than or equal to 4, condition false. We are breaking the loop here. And line number 20, we are printing that factorial value. Factorial of percentage LLU should be referred in variable n. That means 4 factorial will be present here. Factorial of 4 is equal to percentage LLU should be referred in variable called factorial. Let us assume the user inputs 4. So factorial of 4 is equal to 24. Factorial of 4 is equal to 24. The 24 should be referred from factorial variable. The 24 will be referred from factorial variable. The 24 will be displayed onto the output screen. So we'll run this code so that you can able to understand it better. Execute, compile and run. For example, 6 factorial is 720. That is correct. And this program works till 20 factorial only. After that, it won't give you correct answers because the data type size is limited. Okay. So let us say 20 factorial. 20 factorial is something like this. Let us see this is correct or wrong. So I will open Google Chrome. Let us say factorial calculation. Factorial calculation. So let us assume the value is 20. Compute that. So what I am, this is the maximum value we can store in factorial. 2432, this is the exact value we are seeing in the output screen. When it comes to 21, and if you compute the value is 5109, because this is very large number for unsigned long int as well. So it won't give you the correct answer for 21 factorial because the data type size is overflows now. So let me run this code and see this problem again. So 21 factorial we are running in the command prompt. So 14197, this value is not at all matching because of overflow issue. We may not get the correct answers. Okay. So in order to find the factorial of a large numbers or big numbers, we might need to use arrays. So we will see factorial of big numbers using arrays in upcoming lectures. I hope this session is useful. I will see you in my next session. Thank you so much for watching.